Okay, today we're going to be talking about ratios and proportions. This is kind of a review from algebra before we start applying the geometry aspect of it with similarity. So you should be able to use ratios to solve problems involving proportions and similar figures. That's where we're headed with it. First, let's talk about what a ratio is. A ratio is a comparison of two numbers. Two quantities, comparison of two quantities by division. So I can write A over B, that is a ratio, so long as B is not equal to 0. We could also write it A colon B, and this is read A to B. Or the third way that we could write it is A to B. And obviously the most common way to represent it would be as a fraction. We do need to remember that when we represent this, that they are usually going to be represented in simplest form. So in our first example, it says there are 20 sophomores, 5 juniors, and 4 seniors. The ratio of sophomores to juniors is, so sophomores is 20 and juniors is 5. Sophomores to juniors, the first number's in the numerator, second number's in the denominator. I should simplify this since 5 goes into 24 times. This would be 4 sophomores compared to 1 junior. Whichever is number asked for first comes first in your ratio, juniors to seniors. So the number of juniors, 5, to the number of seniors, 4. This is already simplified. Remember, this could also be written this way, 5 to 4, or we could write 5 to 4. But again, most of the time we're going to leave things as a fraction since we're going to do more mathematical things with it, and it's easier to work with that way. Seniors to juniors would then, instead of being 5 over 4, would be 4 over 5, or it would be written 4 to 5 and 4 to 5. Write the ratio of the two measurements, 10 inches to 2 feet. Whichever one comes first goes in my numerator, 10 inches to 2 feet. So this might be like a scale on a map where 10 inches is equal to 2 feet in the real world. And if I took that 10 inches and 2 feet, they're both divisible by 2. So every 5 inches would be the same as 1 foot. And if you're having to use this in class because I've been out, you may need to pause this so students can copy things down. An extended ratio is what happens when you have more than one thing being represented at a time. So, an extended ratio compares 3 or more numbers. So, in an extended ratio, A to B to C, the ratio of the first two numbers is A to B, or A over B. The ratio of the last two numbers is B to C, but it would also be true that the first and the last then would be A to C. When you're looking at a ratio like this, the ratio of 3 sides of a triangle is 5 to 12 to 13. In other words, whatever I'm doing to this 5, I'm going to do to the 12 and 13. And if you don't recognize this particular set of numbers, this is one of the Pythagorean triples that we talked about. It says the perimeter is 90. If the ratios are 5 to 12 to 13. I know that 5 plus 12 plus 13 is not obviously equal to the 90 that they said my perimeter is. So whatever I'm doing to one of these, I have to do to each of them to keep this ratio the same. So if I multiply 5 by x, I would multiply 12 by x and the 13 by x as well, and it should be then equal to my perimeter. So I'd have 5x, 12x, 13x is equal to 90. I would combine all my like terms. 12 and 13 is 25, plus 5 is 30. So I have 30x is equal to 90, and I would divide both sides of the equation by 30, giving me x is equal to 3. It did ask me to find all three sides of the triangle, so I'm going to take 5 times 3, which is 15. I'm going to take 12 times 3, which is my 36, and I'm going to take 13 times 3, which is 39. So my sides of a triangle now are 15 to 36 to 39. There's my three sides of the triangle. A proportion is a comparison of two ratios. It's an equation or a comparison of two ratios. So A over B is a ratio, C over D is a ratio, and they're equal. That makes this a proportion. A and D are called the extreme of the proportion, and B and C are called the means. In every proportion, it has two cross products. Cross product means when you're multiplying across this equal sign, you go from denominator to numerator, denominator to numerator, so it's a cross. And those cross products are called the extremes and the means. In a true proportion, the cross product of the extreme is equal to that product of the means. The product of the extreme and the product of the means. And again, at any point you may need to pause this if it's being used as a lesson. Complete each proportion. This is in the next example. If you'll notice, my extremes have an x and a 7 in it. So whatever I do, I want to make sure that x is going to be being multiplied by 7 to keep my proportion the same. My means have a 6 and a y in it, so whatever I do to keep my proportion the same, I want to make sure that I'm multiplying x by 7. That puts the 7 in the denominator here. And the y by 6, which means the 6 is going to be in the numerator. Since x is in the denominator, to keep x times 7, I want to put my 7 in my numerator on the other side. And to keep it y times 6, I want to put my 6 over here. So x over 6 equals y over 7 is the same as x over y and 6 over 7. Also the same as 7 over y is 6 over x. And now we're just simply going to solve a proportion. And we're going to take those cross products. In other words, we're going to take the product of the extremes, the 6 times the 4x minus 5. And we're going to set it equal to the product of the means, 3 times that negative 26. In order to solve this, we are going to have to distribute. 6 times 4x is 24x. 6 times the negative 5 is negative 30. 3 times the negative 26 is negative 78, we're going to add 30 to both sides. I'm going to have 24x equals a negative 48. And then I'm going to divide both sides by 24. So x is equal to a negative 2. In our next example, again, we're going to take the product of our extremes, 7 times everything that was in the denominator, x plus 4. And it should be equal to the product of my means, 9 times x minus 1. Just like in the last problem, when we go to solve this, we're going to have to distribute this 7 through the parentheses. 7 times x, 7x. 7 times the 4 is 28. 9 times x, 9x. 9 times negative 1, negative 9. When I go to solve this one, because there's x's on both sides, I typically like to move it to where it's the largest. We've been doing this long enough now, we should know how to solve this part of the equation. I'm going to go ahead and subtract the 7x, giving me 2x minus 9. And getting x by itself, adding 9 to both sides, which gives me 37 is equal to 2x. And then I would divide both sides by 2. Here I could leave 37 over 2, or I could do that division, and if I do the division, I'm going to get x is 18.5. Please, when you're doing a problem like this, if it comes out to something that's a repeating decimal, leave it as a ratio. Leave it as a simplified fraction. Don't change it to some kind of repeating decimal. If it comes out to an exact number like this where it's not repeating, it's okay to put it as a fraction. And the assignment for today is straight out of the book, and it is page 436, 1 through 5, 9 through 32, and 40 through 43.